Okay, welcome to the next video. We got interrupted by the bell, but we'll just continue where we left off. If this is going too fast, just please raise your hand and let the substitute know to pause the movie for just a minute so you can catch up. It's hard to gauge how fast I should be talking when I don't have you writing to look at. So here we go. We are now on page 13. So we have talked about how to solve a rational equation, and now we're going to try some simple ones, and then we'll get into some harder ones. So here's the first one. We'll start with this first problem and the third problem because they're pretty similar. You have two fractions that are set equal to each other. So when you have two fractions set equal to each other, the best way to solve this is to cross multiply. So I'm going to cross multiply my 5 times x and write down 5x. Then I'm going to multiply 3 times x plus 1, and I get 3 parentheses x plus 1. So that's cross multiply. So then I need to distribute the 3 and solve for x. So distribute the 3 gives me 3x plus 3. 5x is on the left. Subtract 3x from both sides. 2x is equal to 3. Divide by 3, and x is equal to 3 over 2. Now we've talked a little bit about extraneous solutions. Does this have an extraneous solution? No. So x equals 3 over 2 is fine. Okay. Let's go ahead and look at problem number 3. Same thing. Let's cross multiply. So 10 parentheses 2x plus 1 equals 5 parentheses x minus 4. Distribute the 10, distribute the 5, and solve for x. So there's 20x plus 10 equals 5x minus 20. Subtract 5x from both sides and we get 15x. Subtract 10 from both sides, we get minus 30. Divide by 15, and x is equal to negative 2. Again, x can be negative 2 because your variables are only in the numerator. There's no problems that are going to go bad because of the denominator. So x is 2 is your correct answer. Okay, number 2 is a different type of problem. So I want you to think for a minute. You don't need to write this down, just watch. Here's the idea. If I gave you 1/4 plus 2/4 and added those up, it would equal 3/4. Now, this is true because when you add fractions, you have to have a common denominator. So we've got 4, 4, and 4. Then we just add up the numerator. So 1/2 plus 2/2 is equal to 3, and then we keep the 4 on the bottom. So this is a true statement. 1/4 plus 2/4 is 3/4. It's also a true statement that 1 plus 2 is 3. And this is true without the fraction of the fourth. So what that means is once you have a common denominator, all 3 of your, or 2 of your fractions, whichever the equation may be, all of the fractions have the same denominator, you can totally ignore the denominator and simply add up the numerator. So that's the idea. One more time. You make equivalent fractions so that everything has the same denominator. Once you do that, you can add up the numerator and completely ignore the denominator. And that's the strategy if you have a problem that's not going to be cross multiplied. How do you tell when you should cross multiply and when you shouldn't? Well, in these cross multiply ones, you just have two fractions. You have one fraction equals another fraction. Same thing with number 3. You'll cross multiply because one fraction equals another fraction. However, in problem 2, you have a fraction plus a fraction equals 5. Alright, so we need to find common denominators. So remember that 5 is still a fraction, it's just over 1. Our common denominator will be, let's see what we have. What do we have to work with? A 2 and a 4 and a 1. So we could use 4 as our common denominator. Now, what does each of these fractions need? The x over 2 needs to multiply the top and bottom by 2, so we get 2x over 4. The next fraction already has a 4, so just rewrite the 3x. And then the final fraction, 5 over 1, needs to multiply by 4, so we get 20 over 4. So one more time, we found the common denominator, and then we asked ourselves, what does each denominator in the original problem need so that it can look like a new fraction over 4. We figured out what the numerator needed. Oh, I'm yawning, excuse me. And we added up the numerators. So 2x plus 3x is equal to 20. 5x is equal to 20, and divide by 5, x is equal to 4, and not extraneous. So why didn't we have to worry about extraneous solutions in these 3 problems? Because there were no variables in the denominators. No variables in the denominator. That means the domain for each one of these problems above is all real numbers. We don't have to worry about, so all real numbers for each problem. We don't have to worry about where these things went wrong. Okay. Let's go ahead and solve each rational equation, and then be sure to check your solutions. Now you're going to see that we have x's in the denominator, so we could potentially have extraneous. So after we solve each problem, we're going to check to see if we have an extraneous solution or not. Okay, number 4. It looks a lot like number 1 and 3 above, so we are going to cross multiply. 2 parentheses x minus 3 equals negative 5 parentheses x minus 4. Distribute the 2 and the negative 5, and then go ahead and finish your problem. So 2x minus 6, negative 5x plus 20. We need to get all of our x's on one side, our numbers on the other. I am going to subtract 2x. That gives me negative 7x on the right side. I'm going to subtract 20. That gives me negative 26 on the left side. This one ends up being kind of an ugly fraction, but your x is equal to positive 26 sevenths. So let's recap that problem. We we cross multiplied. Then we distributed 2x minus 6, and then we distributed negative 5x plus 20. We gathered all of our x's on one side, numbers on the other. Okay, so think about the domain for this problem. X cannot be positive 3 or positive 4. Well, our answer is definitely not 3 or 4, so do we have an extraneous solution? No. This answer is correct. Okay, let's go ahead and look at number 5. This one follows the pattern of number 2. So we need to find a common denominator. Once we find a common denominator, we can actually ignore the denominator and just solve the numerators. That's the strategy. So in this problem, our common denominator, let's see, we've got to have an x in each one, and then we need to figure out what's the least common multiple of 4 and 6. I think it's going to be 12. Once we figure out that our denominator is 12x, you need to figure out what each fraction needs. So 4 needs to multiply by 3x. So we multiply the numerator by 3x and we get 3x. The 1 over x needs to multiply by 12. So we multiply the numerator by 12. 1/6 needs to multiply by 2 and x. So the numerator needs to multiply by 2 and x. Now how do I determine what those things are that it needs? Remember that in my first fraction, I started with a 4. I had to change that 4 to a 12x. How do I get from 4 to 12x? I times by 3x. How do I get from x to 12x? I times by 12. How do I get from 6 to 12x? I times by 2x. Whatever you times the denominator by, you also have to times the numerator by. So this one ends up being 2x. Alright, remember, once your denominators are the same, you can just ignore your denominator. Ignore your denominator and just add up the numerator. So this is 3x plus 12 equals 2x. Subtract 2x and you get x. Subtract 12. X is negative 12. That seemed weird. Is that what I got earlier? Yes, that matches my notes. Okay, is this an extraneous solution? Let's check. Our domain for this problem, we only have one variable right here, so our domain is just that x cannot be 0. Well, this is not 0, so this answer works. X is negative 12. This is getting a little bit long, so let's just go to the next page. You're going to do one more problem, and then that's it for today, and I'll let you just get to work. So go ahead and look at problem number 7. And we want to know, as we do these problems, do they have extraneous solutions? And I'll give you an idea. We haven't had one yet that's extraneous, so probably number 7 ends up with an extraneous solution, so you can see how that works. Okay, we need to find a common denominator. We're going to rewrite all 3 fractions. Our common denominator has to include an x. Our common denominator also has to include an x plus 7. Now remember, this x and this x plus 7, they need to multiply by one another. This x is not included with that x. Why? Because you cannot break up this binomial. It has to stay together. So x plus 7, x plus 7, x plus 7. Okay, same process. What does each fraction need? The first fraction needs to multiply by x plus 7. The second fraction needs to multiply by x. So we get x on the top. We got x plus 7 times 1, of course, on the first fraction. And then the third fraction again needs to multiply by x. So we multiply the numerator by x. That gives us x times x plus 8. Okay, your common denominators are the same. You can completely ignore them, and you are left with the problem x plus 7 plus x equals x squared plus 8x. Ignore the denominators. Now, combine terms, get everything on one side. This is 7 plus 2x. We can subtract 2x and also subtract 7. And 0 equals x squared plus 6x minus 7. This is a quadratic. How do we solve this? We are going to factor. What are the factors of 7 that make 6? Probably 7 and 1. We need a positive 6, so we'll have a positive 7 and minus 1. So our answers are 1 and negative 7. But come back over here to our original problem. The domain of our original problem is that x cannot be 0, because if this number right here is a 0, the fraction's undefined. And x cannot be negative 7, because if this number right here is negative 7, then the fraction's undefined. So check your domain with your answers. And we just found out that x cannot be negative 7, so our final answer is just x equals 1. And the extraneous answer would have been x is negative 7. Okay, so there's an example of an extraneous solution. We'll stop right there. So you've had about 20 minutes of video, so you should have about a half hour left in class to work. Be productive. Remember, your assignments are 3, 5, and 3-6. They're both assigned today. They're due separately, so this one is due on Tuesday and 3-6 is not due until Thursday. The end. Have a good weekend. Goodbye.